I am Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic greedy method. In this, we want to discuss about the introduction, job sequencing with deadlines, Prim's algorithm examples, Kruskal's algorithm examples. Many real-life problems are optimization problems. Greedy algorithms tries to find out a solution, optimal solution among many possible solutions. An optimum solution is one in which we want to find the best solution. Greedy method sometimes works well for optimization problems. Greedy method is a simple method of progressively building up a solution by choosing a best element at each stage. At each stage, a decision is made regarding whether a particular input is optimal solution or not. The selection procedure itself based on some optimization measure. In greedy method, a set of feasible solutions are generated. Among them, we can select a best solution. Most of the problems have n inputs and require to obtain a subset that satisfies some constraints. Any subset that satisfies these constraints is called a feasible solution. Any feasible solution that maximizes or minimizes the objective function is called as the optimal solution. Now, we will discuss about the job sequencing with deadlines by using the greedy method. The objective is find a sequence of jobs which is completed within the deadlines and yields maximum profit. Suppose n jobs are there and these jobs are associated with the deadlines, and profit is gained if a job is completed within the deadline. All the jobs have to be ordered in order to get the maximum profit. Sometimes it may not be possible to order all the jobs or may not complete all the jobs within the deadlines, but we have to find out a best sequence so that the total profit will be maximum. Now, let us consider a set of given jobs as shown in the table. The number of jobs, their profits and deadlines are given. Find a sequence of jobs which will be completed within its deadlines and it should yield maximum profit. So here, job 1 profit is 20, job 2 profit is 15, job 3 profit is 12, job 4 profit is 5, job 5 profit is 3. The deadline time in hours is given as for job 2 hours. That means job 1 can wait for 2 hours, job 2 can wait for 2 hours, job 3 can wait only for 1 hour, and job 4 can wait for 3 hours, job 5 wait for 3 hours. That means the total number of slots available in this case is only 3 slots. That is 0 to 1, 1 to 2 and 2 to 3. So these 3 slots are there. Based on that, we have to select the jobs so that the total profit will be maximum. Now, so in this, we have to select the job which has maximum profit. So now you see here 5 jobs are there. For the first job, the profit is 20. In that, we can consider this table. Job considered, slot assigned, solution, profit in rupees. So beginning, there is no job considered, no slot, solution is 5, profit is 0. Now, the first job is having maximum profit, so that we can select that one, J1 here. job considered is J1. Slot. So the first job can be waited for 2 hours. We can assign the first slot or second slot. Now we can assign slot assigned is 1 to 2. The slot assigned is 1 to 2 and slot assigned is 1 to 2. Then the solution is J1 and the corresponding profit is 20. Corresponding profit is 20. Next, we can select the next job. Second job is having highest profit that is 15. Now, the job considered is J2 and the slot assigned. This can also be waited for 2 hours, but the first slot is free now, so that we can assign first slot 0 to 1. And job considered here is J1 comma J2 is the solution and the profit is 20 plus 15 that is equal to 35. Then coming to the next, only one slot is available that is 2 to 3. So next job is J3 but the J3 can wait only for 1 hour, that is not possible. So J3 cannot be considered here. Then the slots arranged are 0 to 1 and 1 to 2. So here 0 to 1, 1 to 2. Then this is only J1, J2. J2 is not considered. The profit is only 35. Next, J4. So we can consider J4 because he can wait up to 3 hours. So that we can consider this one. So that 0 to 1, 1 to 2, 2 to 3. And the solution is J1, J2 and J4. And the profit is 30 plus 5, that is 40. So like that we can sequence the jobs. Now you see, first we have to consider the J1. The slot assigned is 1 to 2 and solution is J1 and profit is 20. Next, J2 is considered and the first slot is given and solution is J1, J2. The profit is 20 plus 15, that is 35. Next case, J3 is not considered because he will wait only for 1 hour. That slot is already filled. So that the solution is 0 to 1, 1 to 2, J1, J2. 20 plus 15 is 35. Next, J4. J4 can be considered. So he can wait up to 3 hours. So that can be considered in the slot 2 to 3. And the solution is J1, J2, J4. And profit is 35 plus 5 is equal to 40. And J5 there is no slot. So that it cannot be considered. The total profit is only 40. Now, consider another problem. Let us consider a set of given jobs as shown in the table. The number of jobs, their profits and deadlines are given. Find a sequence of jobs which will be completed within its deadlines and it should yield maximum profit. Now, in this case, 7 jobs are there and the profit corresponding to the first job is 35, second job is 30, third job is 25, fourth job is 20, fifth job is 10, sixth job is 8, seventh job is 6. The deadline is first job can wait up to 3 hours, second job 4 hours, third job 4 hours, fourth job 2 hours, fifth job 3 hours, sixth job 1 hour and seventh job 2. So the total time is only 4 hours. So that how many slots are there? That is 0 to 1, 1 to 2, 2 to 3 and 3 to 4. Only 4 slots are available. But 7 jobs are there. So we have to select the sequence so that our profit will be maximum. Now, 4 slots are 0 to 1, 1 to 2, 2 to 3, 3 to 4. 4 slots are there. Now, so first no job is considered. Slot assigned is nothing is assigned. Solution is 5. Profit is 0. Next, the first job is having highest profit, so that we can consider J1 and slot assigned. Now you can see it can wait up to 3 hours. That means we can consider the slot 2 to 3. 2 to 3 can be considered for the first job, and the solution is G1 and profit is 35. Next, second, after first job is allotted, next we have to see the second job. Second job can be waited up to 4 hours. That means it can be considered, and the profit is also maximum, so that J2 can be considered here, and the slot assigned is 3 to 4 can be considered. We are already assigned 2 to 3 for this, so next slot can be considered, and the solution is J1 comma J2, and the total profit is 35 plus 30, that is equal to 65. Total profit is 65. Next, third job. Third job is can wait up to 4 hours, but 2 slots are over, so we can consider the first slot or second slot. So the total time available is so total profit is 25. So now you can consider the slot J3, and the slot we can assign is, so you can wait up to this, but we can assign the first slot we can assign, or second slot we can assign, so that this is 1 to 2, 2 to 3 and 3 to 4. So that is G1 comma J2 comma G3. The solution 35 plus 30, the profit corresponding to the third job is 25, so that it is 90. 65 plus 25 is 90. Now next one is second job. Second job, the profit is 20. Second job profit is 20, and you can wait 2 hours. So the first slot is free, so that we can assign fourth job, and the first slot can be considered for him 1 to 2, 2 to 3 and 3 to 4. So 4 slots. The jobs are J1, J2, J3 and J4. So profit is 35 plus 30 plus 25 plus 20, that is 110. Next, J5 slot is not there, J6 slot is not there, and J7 slot is not there, so that the solution is same, so that the total profit is 110, and the jobs considered are J1, J2, J3, J4 only. Now you see, the first slot is assigned here for the first job, that is solution is J1, profit is 35. Next, second job is considered. For the second job, the third slot is given. Third slot is for the second job, third slot is given, and the solution J1, J2, profit is 35 plus 30 is 65. And J3 can be given second slot 1 to 2, then the solution is and remaining jobs will be as it is. The solution is J3, J1, J2, and profit is 65 plus 25 is 90. So J4 profit is 20, and 2 hours it can wait. The first slot is free, so that we can assign the first slot. Then the slots assigned 0 to 1, 1 to 2, 2 to 3, 3 to 4, and jobs are J4, J3, J1, J2, and the total profit is 110. For the jobs J5, J6, J7, time is not slots are not available, so that we cannot assign. So the maximum profit we can obtain is only 110. Next, the another method is Prim's algorithm. Prim's algorithm is a greedy algorithm that finds minimum spanning tree for a weighted undirected graph. This means it finds a subset of the edges that form a tree. The subset includes every vertex where the total weight of the edges in the tree is minimized. In this, any vertex can be considered, or the subset includes every vertex where the total weight of the edges in the tree is minimized. In this, any vertex can be considered as a starting vertex, and at each step, low-cost edge can be added to construct a tree. In Prim's algorithm, graph is represented by a set of vertices and a set of edges. So, V is the number of vertices, where E is equal to V represents number of edges. So, the time complex is represented by theta of V dot E, that is equal to theta of n into n minus 1, where n is the number of vertices, E is number of edges. Now, consider this problem. Use Prim's algorithm to find a minimal spanning tree for the graph shown below, starting with the vertex A. So, in this, first we have to remove all the loops or parallel edges. That is the first step. Then next step is we can consider any vertex as the starting vertex, but in this case consider the vertex A is the starting vertex. Next, consider the nearest or low cost edge. Now consider the low cost edge. That means now consider the vertex nearer to A. Now consider, because we are selecting vertex A is the starting vertex. Now select a vertex nearest to A. Now here A is the starting vertex. The nearest vertex to A is one is B, another one is C. Now can go to the next slide. Now parallel edges are removed. So first you can select this is the starting vertex. Now the nearest one is B. So select B. Now select a vertex either nearer to either A or B. That means you can select. So for B, C is nearest, so that you can select this, okay, and draw a solid line between B and C. Next, select a vertex nearer to A or B or C. A or B or C. So the nearest vertex to C is E, because it is having only 3. That is E. Now select a vertex nearest to A or B or C or E. Now you can consider D is nearest to E, so that you can consider this. This is D. D is nearest to that. Now select a vertex nearest to A or B or C or D or E. Now F is nearest to E, so select the vertex F. Now like that you have to select the vertices. Now you can see here in the first, so we selected the vertex B, so draw a solid line between A and B. Next, C is nearest to B, so again we draw a solid line between B and C. That means these 3 vertices are selected. Now select a vertex nearer to A, B or C. In the next stage, now we have to select a vertex nearer to A, B or C. Now vertex E is nearest to C, so that draw a solid line between C and E. Now select a vertex nearest to A, B, C or E. Now the D is nearest to E, so draw a solid line between E and D. Then select a vertex nearer to A or B or C or E or D. Now the vertex F is nearer to E, so that draw a solid line between E and F. Now this is the minimum spanning tree. The distance is 17. 7 plus 3 10, 10 plus 3 13, 13 plus 2 15, 15 plus 2 17. So like that we have to find out the shortest distance or minimum distance. Now consider the another problem. Use Prim's algorithm to find a minimum spanning tree for the graph shown below, starting with the vertex A. Now the first step here is again remove the parallel edges and loops, and then select the vertex A is the starting vertex. So vertex A is the starting vertex. Now select a vertex nearer to A. That means A to B is 3, A to C is 6. So that B is nearest. So select B. The distance is 2. The distance is 3. Now select a vertex nearest to either A or B or C. So the vertex C is nearest to B. So draw a solid line between B and C. Next, select a vertex nearest to A or B or C. Now vertex D is nearest to C. Draw a line with solid line between C and D. So C and D. Next, select a vertex nearer to A, B, C, A or B or C or D. So now here from C to F it is to D to E, it is to anyone you can consider. Suppose if you consider D to E, you can write like this. Draw a solid line between D to E. And next C to F. C to F, you can draw a solid line here that is selected. Next E to F. E to F, the next lowest is E to F. So E is nearest to F. E2 is nearest to G, so that we can consider E to G is this. Next, E to F is 2, but we should not consider that because all are connected, so that the solution is obtained. Now you can see first the B is nearest to A, so that draw a solid line between A and B. This is represented here. Next, the vertex C is nearest to B, so a solid line is drawn between B and C. Now, the vertex D is nearest to C, so that a solid line is drawn between C and D. So, A to B, B to C, C to D. Next consider a vertex nearer to A or B or C or D. So, E is nearest to D. So, draw a solid line between D and E. Now, so you select A, B, B to C, C to D, D to E. Next, select a vertex nearer to E. F is nearest to this, so that you can select and draw a solid line between E and F. Next, this F is nearest to G, so that draw a solid line between F and G, so that you can get a spanning tree. Now here you can connected, all are connected, all the nodes are connected. So what is the minimum distance? 3 plus 2 plus 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 1 8, 8 plus 2 is 10, and 10 plus 1 is 11. So by using the Prim's algorithm, you can find out a minimum spanning tree. In the same way, we can also find out a minimum spanning tree by using the Kruskal's algorithm. Kruskal's algorithm is also a greedy algorithm that finds minimum spanning tree for a weighted undirected graph. This means it finds a subset of the edges that forms a tree. The subset includes every vertex where the total weight of all the edges in the tree is minimized. In this, low cost edge can be considered in every time, and it is represented by a solid line. The procedure is repeated until minimum cost spanning tree is obtained. Cycle should not form while selecting the edge. In Kruskal's algorithm, graph is represented by a set of vertices and a set of edges, that is G of VE, where V represents the vertices, E represents the edges. The time complexity is again theta into VE, theta of n into n minus 1. The time complex can be reduced by considering a minimum heap. Now, Kruskal's algorithm to find a minimum spanning tree for the graph shown below. Now, in this, we have to select a low cost edge. We need not start with the vertex A. You can select any edge which is having low weight. So first step is remove the parallel edges and loops. Then you select a edge which is having very low cost. So among all the edges, CD is having C, D. The edge first list out all the edges in increasing order. So now first you can write C, D is 1. Then EG, EG. This is CD is 1, EG is 1. First list out the edges in a increasing order. So EG is over, CD is over. Next BC. BC is 2. BC is 2. Then next DE, BC, CF. CF is 2. CF is over. Then DE. DE is also 2. Then D is over. Then EF. EF is equal to 2. So EF is over EG. EG is 1. Then you can see here 2. EG is 6. FG is 1. So here this is FG. So EG is 6. FG is equal to 1. EF is equal to 2. Then EF is over. EG is over. Then next is 2's are over. Next AB. AB is 3. AB is 3. Then BD. BD is 4. BD is 4. Then BD is over. CE. CE is 4. CE is 4. And DG. DG is 5 and EG is 6 and AC is also 6. So first of all we have to list out the edges and then we have to arrange the edges in a increasing order. So first CD is 1, then FG is 1, then BC is 2, then CF is 2, then DE is 2, then EF is equal to 2, and AB is 3, then BD is 4, then CE is 4, then DG means this one 5 and AC is 6. So first of all we have to list out the edges and then we have to arrange the edges in a descending order, increasing order. Now you see here CD1, FG1, BC2, CF2, DE2, EF2, AB3, BD4, CE4, DZ5, EZ6 and AC6. Now, so after this one, so first select the edge CD. So CD here. CR and D are in a separate sets so that we can join CD and draw a solid line between CD. Then next lowest is FG. FG is also 1. So F and G are in a different sets, so you can consider FG. Now next BC. B and C are in different sets, so that we can consider B comma C. We can consider B comma C as a combined edge. Then CF. C and F are in a different sets, so that we can consider the C and F and draw a solid line between C and F. Next, DE. So D and E are in a different sets, so that you can write DE. Also we can write here DE. Then EF. EF means, so while selecting an edge, loop should not form, so that when you join E and F, loop is forming. That means it should not be considered. Next, AB. A and B are in different sets, so that you cannot, you can combine that one. So draw a line AB between, like this. Consider the edge AB. Then BD. BD we cannot consider, because again BD, if you join, a loop will come, so that it cannot be considered. Then DG. DG also we cannot consider. DG also we cannot consider. CE also we cannot consider. Then EZ. EZ also we cannot consider, because loop is forming. AC. AC also we cannot consider, the loop is forming. Now we can come step by step. First, CD. CD is the lowest cost edge. So draw a solid line between C and D. Why? The vertices C and D are in different sets, so CD is a combined edge. The vertices C and D are in different sets, so CD is a combined edge. So this indicates that CD is connected. A, B, E, F and G are to be connected. CD is connected. Next step, FG. F and G are in different sets, so draw a solid line between F and G. So FG. Then here edge sets CD and FG are connected. A, B and E are to be connected. A and B are to be connected. Next. So CD is over, FG is over. Next, edge is BC. BC here. So B and the vertices B and C are in different sets. So BC is a combined edge. BC is a combined edge. So draw a solid line between B and C. So draw a solid line between B and C. Then C and F. C and F. So C and F are the vertices C and F are also in different sets, so that you can draw a solid line. That means CF is a combined edge. CF is a combined edge. Now these edges are combined: BC, CD, CF, FG. So B, C, D, E, F, G are connected. Only the vertices A and E are to be connected. Next, after CF, next one is DE. So the vertices D and E are in different sets. So DE is a combined edge. DE is a combined edge. So draw a solid line between D and E. Next, EF. EF, if you want to, now you consider EF. Now you see, if you join E and F, the loop is forming. That means CDEF is a loop. So that you should not consider the edge EF, because the vertices E and F are in the same set. So EF is rejected. Why EF is rejected? The loop is forming, or the vertices E and F are in the same set. So EF is rejected. Next, DE. D is over, EF is over. Next, AB. Now AB, the vertices A and B are in different sets. So AB is a combined edge. A and B are different. The vertices A and B are in different sets. So AB is a combined edge. Join A and B by a solid line. So here all the vertices are connected. A, B, C, D, E, F, G. All the edges are connected. Next, BD. So there is no change in the diagram. Because all are connected. The vertices B and D are in a different. The vertices B and D are in the same set. So BD is rejected, because the loop should not form while selecting an edge. Next, CE. Again, if you see here, if you join CE, the loop is forming. So we should not consider that. So that means the vertices C and E are in same sets. So CE is rejected. Next, DG also. If you consider DG, now you see D and G. If you consider D and G, again loop is forming. So loop is forming. That means loop should not form while selecting the edge. Then, so there is no change. The diagram will be as it is. Again, next coming to the edge EG. EG is concerned. Again, the loop is forming. How the loop is forming? C, D, E, G, F is a closed loop. The cycle is forming. In that case, we should not consider that one. Cycle or loop should not be formed. So that EG is rejected. That means the vertices E and G are in the same set, so it is rejected. Next, coming to the AC. AC also loop is forming. If you join AC, a loop is forming, so that it is also rejected. Why it is rejected? The vertices A and C are in the same set, so it is rejected. Now, all the vertices are connected and the minimum distance is 1 plus 1, 2 plus 2 plus 2 plus 3, so that the total distance is 11. Now, consider the another diagram, another problem. So, use Kruskal's algorithm to find a minimal spanning tree for the graph shown below. Now, here loop is there. First, remove that loop and then write the list of edges. Now, you write the list of edges. What are the list of edges? Here, you can write in the increasing order. In the increasing order. So, what is the smallest cost edge? DE. DE is 2. DE is 2. Then EF. EF is 2. DE, EF is 2. Then next CD. CD is CE is 3. And BC, you can consider BC. BC is 3. And CE is 3. In increasing order, we have to select. DE is 2 and EF is 2 and BC is 3 and CD is 3. Next, 4. That means CD. CD is 4. CE is 3. CD is 4. Then DF. Next, DF. DF is 5. DF is 5. DF is 5. DF is 5. Then VD is 6. VD is 6. AB is 7. AB is 7. AC is 8. Is 8. CD. CD is 4. Now, first AB is 7. AC is 8. BC is 3. BC is 3. CD is 4. And DE is 2. EF is 2. DF is 5. So, first of all, we have to list out the edges in the increasing order. After list out the edges, then we have to follow the procedure to select the minimum constructing the minimum spanning tree. So, DE is 2, EF is 2, BC is 3, CE is 3, CD is 4, DF is 5, BD is 6, AB is 7, AC is equal to 8. Now, you see it is arranged here. For that, I will explain here. So, the lowest cost edge is DE. So, first select D and E. DE is selected because it is the low cost edge. Next is EF. So you can consider E and F, because here first D and E are in different sets. So draw a solid line between D and E because DE is a combined edge. Next, E and F are also the vertices. E and F are in different sets. So draw a solid line between E and F because EF is a combined edge. Next, BC. So you draw, you select a edge BC because next lowest edge is the BC. So select B and C are also in a different sets. So draw a solid line between B and C. Next, C and E. Now C and E are in a different sets, so that you can draw a line between C and E. C and E can be joined because no loop is forming and these C and E are in different sets. Next, CD. Suppose if you CD, now you see when if you join CD, loop is forming or cycle is forming. And so in that case, you cannot select CD. The edge CD cannot be considered because loop is forming. That means C and D are on the same set. So we can reject that CD. Next, coming to the DF. So if you consider DF also, cycle is forming. So that you cannot consider the DF because D and F are in a same set. So we can reject that edge DF. Next, BD. BD, if you consider again, BD, loop is forming. If you consider, so now if you consider BD, loop is forming. So that means you should not consider that. That means B and D are in the same set. We can also reject BD. Next, AB. AB, now A and B are in different sets. A and B are in different sets, so that we cannot different sets, so that we can combine that edge A and B. You can join A and B by a solid line because A and B are in different sets. Join A and B. It is a combined edge. Now you see here AB is over. Next, AC. So A and C are on the same set. So we can also reject AC because already these vertices are connected. A, B, C, D and E, F all are connected. So it is the minimum distance. All are connected. Now you can come step by step. First is C. DE. DE means, so the cost is only 2. Now you see the vertices D and E are in different sets. So DE is a combined edge. So this indicates that the vertices D and E are edge DE is connected, and the vertices A, B, C and F have to be connected. A, B and C, F have to be connected. Next, after completing DE, coming to the EF because it is also next lowest one. Now E, the vertices E and F are in different sets. So EF is a combined edge. EF is a combined edge. DE is connected, EF is connected. So you can write here DEF. DEF is connected. A, B and C have to be connected. Next, after EF, the next one is BC. Now coming to BC, the cost is 3. Now see whether B and C is connected or not. So B and C are in different sets. B and C are in different sets. Here DEF 1. B and C are in different sets. That means you can draw a solid line between B and C because it is a combined edge. Now B and C is a combined edge. So D vertices D, E, F, B and C are connected. A have to be connected. Have to be connected. Next, coming to the when BC is over, next one is CE. Now coming to its cost is also 3. Now see whether E and C are in the same set or different sets. So now the vertices C and E are in different sets. So CE is a combined edge. CE is a combined edge. So draw a solid line between E and C. Next, CD. If you consider CD, loop is forming. Now you can see here, if you consider CD, loop is forming or cycle is forming. So in that case, we cannot select that edge CD. Now that indicates that the vertices C and D are in the same set. So CD is a rejected. CD is rejected. Next, DF. DF also. If you consider the edge DF, again loop is forming or cycle is forming. So when the cycle is forming, we should not consider the corresponding edge. That indicates that the vertices D and F are in the same set. The vertices D and F are in the same set. So DF is a rejected. DF is rejected. Next, BD. Now you see BD. So if you join BD, again cycle is forming. What is that cycle? BDECB. BDECB is the cycle. So should not form. While selecting any edge, the cycle should not form. So reject that edge BD because the vertices BD, B and D are in same set. So BD is rejected. BD is rejected. After BD, next coming to the AB. AB here. Now see whether A and B are in different sets are in the same sets. So now you see A and B are in different sets. So draw a solid line between A and B because A and B is a combined edge. A and B is a combined edge. So any loop is or any cycle is not forming here. So that's why we joined A and B. Next, AC. AC, A and C are in the same set. Suppose if you join AC, again the cycle is forming. What is that cycle? A, B, C, A is a cycle. So cycle should not form. That means A and C are in the same set. So it is rejected. A and C are in the same set. So it is rejected. Now you see all are connected. All the vertices are connected. What are the vertices are A, B, C, D, E and F. All the vertices are connected and the corresponding distance is, so here you can see AB is 2, BC is 2 and CC you see here 2 plus 2 plus. Now AB is 2. You can see the distances. AB is how much? AB is 7. So AB is 7. That means when AB is 7, so here AB is 7. 7 plus, you can find out, AB is 7. So this is completed cycle. AB is 7. Then BC is how much? BC is 3. BC is 3. Then EC or CE is 3. CE is connected. DE is connected. DE is 2 and DE is 2. EF is connected. That is 2. Now you can find out 7 plus 3, 10 plus 3, 13, 13 plus 2, 15, 15 plus 2 is 17. So all the vertices are connected and the total or the minimum distance is 17. So all are connected, minimum distance is 17. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.